This lesson is about evaluating functions. We learned that functions can be given in different forms. For example, they can be given as a word description, an equation, set of ordered pairs, a graph, arrow diagram, or any other means that will describe how to find the unique y value for the given input x. To evaluate a function at the given x value, it means to find f of x that is assigned to x by this function. So here we have a couple examples. For each of the given functions, we have 5 different descriptions of functions. We need to find what f of -2 is. In the first example, the function is given by the equation. It's a quadratic trinomial. So to figure out what f of -2 is, we need to replace all occurrences of x by the input -2. My suggestion would be every time you see an x, put a bracket. So rewrite your function the same way as it was, but instead of x, use a bracket. And now the input -2, this is the value of x that we need to plug in whenever you see a bracket. So the rest of it is just follow order of operations and calculate. Copy the negative. -2 squared becomes +4. Then we have two different signs, so it's -2 and -1. Altogether, -7. Therefore, f of -2 is equal -7. Let's see example B. Here the function is given by a set of ordered pairs of numbers. And since the input is -2, we're looking for an ordered pair that will start with -2. And we see that the output that is assigned to the -2 is equal to 4. Therefore, we can state that f of -2 is equal to 4. In the next example, our function is given as a table of values. Again, the input is -2, therefore the output is 3. So we know that f of -2 is equal to 3. Function f maps the input -2 onto the output 3. In the fourth example, we have arrow diagram. We start with domain that includes -2, and following the arrow, we know that the value attached to -2 is equal to 5. So we can state f of -2 equals 5. And finally, we have a word description. Function f triples the input and then subtracts it from 5. So maybe first let's translate this word description into an equation. Our function f takes an input x, and what is it doing with it? Triples the input and then subtracts it from 5. Since subtract from is a backward structure, we need to start with 5 and subtract from it, triple the input, so 3 times x. And now, since we already have the formula for the function, it's easy to evaluate f at -2 just by replacing x by -2. So we have 5, and then we multiply negative times negative numbers, so it's +6. Therefore, altogether, we've got 11. f of -2 is equal 11. In the next example, we have given linear function f, 3x minus 1, and we need to evaluate what f of -2 is. As before, we need to replace the input x by the new input, which is called -2. So 3 times a bracket minus 1, and the value that goes into this bracket is -2. That's the x value. So overall we have -6 minus 1, which is -7. f of -2 is equal -7. Now let's do the same, but using a general input that is called -x. Not x, not particular value, but -x. Let's follow exactly the same rule. We're going to write the function, and instead of the old input, put a bracket. Now, inside this bracket, we'll write whatever the input for the function is. In this case, it's negative x. So we place negative x here. Now let's simplify this formula. That becomes negative 3x and negative 1. Therefore, function f is transporting negative x into negative 3x minus 1. Next, we need to evaluate f of a. Similarly as before, we follow the formula of the function 3 times the input minus 1, but the input is called a. So we'll write 3 times, you can write a bracket, or you can see it once that this is your a instead of x, minus 1. So f of a is 3a minus 1. Okay, but maybe next time the input is even bigger expression. It can be any expression that involves x, can be any expression that doesn't involve x, can be any numerical value. So how do we deal with this? Again, similarly as before, write down the 3 and open a bracket to leave the room for the input. The input can be as large and ugly as you only can imagine. We can still put it inside the bracket wherever the old x was before. So our input here is a plus 1. We write a plus 1 inside the bracket. Therefore, when we simplify this expression, it becomes 3a plus 3 minus 1, so overall 3a plus 2. This tells us that function f is transporting a plus 1, the input a plus 1, onto the output 3a plus 2. Finally, let's try to evaluate this bigger expression, the difference of two values of function f at different inputs. So the first one, f of a plus 1, we already dealt with this in the previous line. It's here. Again, we start with 3. We leave the room for the input and minus 1. And the input is called a plus 1. So this part represents just f of a plus 1. Now what we need to do is to subtract, and since we subtract and we expect something bigger than one term after the subtraction sign, we need to put a bracket. We need to open the bracket here. This is very important. There's lots of mistakes by just not opening this bracket here. So inside this big bracket, we are plugging f of a. But what's f of a? Well, we already calculated this, but even if not, you just follow the function, instead of x, plug in a. So it's 3a minus 1. Complete the bracket. So this part represents f of a. And altogether we have f of a minus 1 minus f of a. Now what's left is just to simplify this expression. So we open all brackets, 3a plus 3 minus 1 minus, open bracket, change signs, plus 1. And we see that 3a can be reduced with the negative 3a and 1 with the negative 1, and we end up with just 3. So the overall answer for this difference of two values is 3. In the next example, we are asked to graph the given functions and then state their domains and ranges. So this is function g of x, and we have a prepared piece of graph paper. So on the y-axis we'll have g of x values. Since we know that this is really a linear function and we know how to graph a linear function, let's recall the free term is our y-intercept. So we'll plot 1/2 on the y-axis. Here I assume that 1 square represents 1 unit. So 1/2 is somewhere there. And we go by the slope, negative 2/3. Remember, the top number represents the rise or fall. If it's negative, in this case it will be fall. And the bottom number represents the run. So starting from 1/2, we're running 3 steps, 1, 2, 3. And we're falling 2 steps, 1, 2, and plot a point. So those are the 2 points that we need to connect. take a ruler, and the graph goes somehow like this. So we have x-intercept 1, y-intercept 1/2. We have a decreasing line. What are the domains and ranges? Domain of the function g is, well, remember, domain can be seen when you project your graph onto the x-axis. So let's project it. It basically covers entire number line. So our domain of the g function is all real numbers. The range of the g function, well, to see the range, we project our graph onto the y-axis, vertical axis, and as you see, a line like that covers entire number line, the y value. So again, the range of g is also all real numbers. How about function h of x equals -2? Since this function is called h, then on our vertical axis, we should write h of x rather than y. And the function looks like it's a constant function. No matter what the x is, the h value will be -2. So we can plot a few points, and you can see this function is actually the horizontal line that passes through the point -2. So what's the domain of function h? I use a subindex here, domain of g, domain of h, just because this way we know which function we refer to. So domain of h, when you project your graph onto the x-axis, everything is covered. Entire number line is taken. So it's not a problem. Domain of h is all real numbers. However, the range of h function, when we project all those red points, all the points from the graph onto the vertical axis, only one point will be shadowed, and that's -2. Therefore, range of h is just one single point, -2. Well, let's practice a little bit more of evaluating functions. Here we have two functions given by a formula. The f function is a linear function and g function is quadratic. We need to evaluate first f of -1. So that's something that we already know how to do. We just replace x by -1. We need to be careful with order of operations when we evaluate. So this is 1. And here 2 negatives when multiply becomes +2. Altogether we have value 3. Similarly, g of -1, replace x by -1. Good idea to use brackets. So our x, which is -1, was squared, then -4 times the x, which is -1. Okay, we have -1 squared becomes +1, and 2 negatives makes it +4. Altogether, the value is 5. G of -1 equals 5. Let's see the next question. Well, in this question, we refer to two different functions. So let's do it one at a time. G of -2, we refer to the g function, which tells us take the input, which is -2, square it, and subtract 4 times the input, -2. Now we have a subtraction. I'm going to use different color to indicate subtraction. Since I am subtracting f of 2, which is a little bit bigger than one term, remember to put a bracket. In this bracket, we need to write f of 2. So follow the f function. It tells us to take 1 and subtract twice the input. The input for f is 2. So 2 times 2. And finally, let's evaluate this. -2 squared is +4. Here we have 2 negatives, so it's +8. Keep the minus, keep the bracket. And here we have 1 minus 4, so it's -3. Okay, so 4 plus 8 is 12. 2 negatives plus 3, altogether 15. This whole expression is equal to 15. In the next example, we're asked to evaluate f of a. So follow the f recipe, which is 1 minus 2 times the input, but the input is called a. So it's 1 minus 2a, and that's all what we need to do here. In example E, we need to calculate f of a plus h. Okay, follow the f formula again, so it's 1 minus 2 times the input. The input is quite large, so I put a bracket here, and the input is called a plus h. Plug in a plus h. Obviously, this can be simplified. It becomes 1 minus 2a and minus 2h. When we open the bracket, the minus will reverse this sign to negative. Now let's look at this exercise. Here we're asked to evaluate f of a plus h minus f of a. But we already know how much is f of a plus h. Is this much. And then we need to subtract f of a, which is that much. So let's put this together. 1 minus 2a minus 2h. We subtract. Make sure you open a bracket here, because we subtract more than one term. And that becomes 1 minus 2a. All together, open the bracket and simplify terms. Minus 1 plus 2a. It turns out that 2a will be reduced with negative 2a and 1 with negative 1. So the overall answer is just negative 2h. Final answer. And let's try the last exercise. Maybe this time I would encourage you to stop the video and try this by yourself and then check your answer with the video. Okay, so to evaluate g of negative x, we follow the formula g of x, which tells us to square the input. However, the input is negative x. Square it and subtract 4 times the input, which is negative x. Now we have a minus, open a bracket, and we need to plug in the expression g of x. G of x again is x squared minus 4x. Okay, and open brackets and simplify everything. So negative x squared is just x squared, because negative square becomes positive. 2 negatives makes it plus 4x. Then open the red bracket and becomes negative x squared plus 4x. See if we can reduce something. The x squared with negative x squared is reduced, and we end up with 8x as an overall answer.